Hello and welcome to this week's Solution Saturday. In this video, we're going to go through question 11 from the MGS 2016 Paper B. Make sure to check out the other videos in the playlist for more worked solutions for this paper. And subscribe so you don't miss out on any of our other videos. The output of a heater is measured in watts and kilowatts. 1 kilowatt is equal to 1,000 watts. So, for example, a 2.6 kilowatt heater produces 2,600 watts. The retention factor, or RF, of an insulating layer shows what percentage of the heat that reaches the insulating layer is kept in, and also allows you to work out what percentage of the heat escapes from the other side. The table below gives you some examples of the percentages for certain RFs. Use the patterns in the table to work out the percentages you'll need in the questions. This means that, for example, with a 5 kilowatt heater, the number of watts escaping through a 60 RF layer is given by 5,000 times 40 over 100, which is 2,000 watts, or 2 kilowatts. Using this method, work out the answers to the following questions. With a 3 kilowatt heater, how many watts of heat escape through a 70 RF insulating layer? The first thing we want to do is convert 3 kilowatts into watts. So we do 3 multiplied by 1,000, so we get 3,000 watts. We know that the heater is 70 RF, which means that 70% of the heat stays in and 30% of the heat goes out. To calculate our answer, we need to do 30% of 3,000. So we're going to do 3,000 multiplied by 30 over 100. Which gives us our final answer of 900 watts. With a 2 kilowatt heater, how much heat escapes through two 90 RF layers put side by side? As we did in the previous section, let's start by converting 2 kilowatts into watts. So we need to do 2 multiplied by 1,000 to get 2,000 watts. Let's tackle each layer one by one. The first layer is 90 RF, which means that 90% of all of those watts is staying in, and 10% is being let out. So we need to do 10%, or 10 over 100, of 2,000, which gives us 200 watts. Let's take a moment to visualize this. If we've got our heater and one 90 RF layer, and then another, this first layer is going to take 10% of the 2,000 watts, but the second layer is going to take 10% of whatever's been let through here. So, even though our next layer is also 90 RF, we need to do 10%, or 10 over 100, multiplied by 200 watts instead of 2,000, as 200 watts have been let through the first layer. 10% of 200 gives us our final answer of 20 watts. With a 1 kilowatt heater, how many 80 RF layers are needed so that the heat that escapes is less than 5 watts? Again, let's start by converting 1 kilowatt into watts. We know that we have to times it by 1,000, so we know that we have 1,000 watts. We also know that with an 80 RF layer, we have 80% of our watts staying in and 20% going out. This part of the question has a similar principle to the previous one, where we have to keep doing a percentage of the remaining watts that go through each layer. So, if we do 20%, or 20 over 100, times 1,000, we get 200. That's our first layer. Now, we have to do 20% of 200, which gives us 40. That's our second layer. Let's keep doing this until we get an answer that's less than 5 watts. .6 is definitely less than 5, And we got that answer after 4 layers, so we know our answer is 4. A 4 kilowatt heater is in front of 3 layers, with a 50 RF layer nearest the heater, then a 40 RF layer, then a 30 RF layer. What heat escapes between the second and third layers? First, let's draw ourselves a diagram to make this easier to visualize. We have our 50 RF layer, then we have our 40 RF layer, and finally we have our 30 RF layer. The question is asking us what heat escapes between these 2 layers, so what we really have to do is figure out the number of watts escaping after the 40 RF layer. First, what we have to do is figure out the number of watts escaping after the 50 RF layer. So let's do that like we've been doing in the previous parts of the question. We know that 4 kilowatts is equal to 4,000 watts. We also know that with 50 RFs, 50% of the watts are staying in and 50% of the watts are escaping. So we need to do 50 over 100 multiplied by 4,000 watts, which gets us 2,000 watts. That's how many watts are going through the 50 RF layer. Now we need to figure out how many watts are going through the 40 RF layer. Using our same method, we know that with a 40 RF layer, 40% of the watts are staying in and 60% are escaping. So we need to do 60 over 100 multiplied by 2,000 this time, which gets us a final answer of 1,200 watts. And finally, from a 4 kilowatt heater, only 108 watts escape through 3 identical layers. What is the RF of each layer? First, let's convert 4 kilowatts into watts. We know this is 4,000 watts. The easiest way for us to go about this question is to figure out what percentage 108 is of 4,000. We do 108 over 4,000, which simplifies down to 27 over 1,000. We do this by dividing both sides by 4. Now let's go back to the question and look at the phrase 3 identical layers. This piece of information is a lot more telling than you might think. 3 identical layers means that we're doing the same percentage 3 times, which means that we're multiplying our numbers by the same fraction 3 times. To reverse this process and to get our original fraction, we can do the cube root of 27 over 1,000. The cube root of 27 is 3, and the cube root of 1,000 is 10. This means that our fraction for each layer, instead of all 3, is 3 over 10, which is the same as 30%. If 30% is being let through each time, that means that our layers are keeping in 70% of our watts. If 70% is being kept in, we know that each layer is a 70 RF layer. And that's our final answer, 70 RF. Thank you for watching. We hope you've been able to gain valuable skills that you can apply to problems similar to this one. If you have any questions, don't hesitate to leave a comment or reach out on our other platforms. Check out the other videos in the playlist for more solutions on tricky questions from this paper.